Hello everyone. Let us start our today's science class with the thought look for something positive in each day, even if some days you have to look a little harder. Children, we have started lesson number 7 metals and non-metals. In earlier videos, we have seen the physical properties of metals and non-metals. Today, we are going to discuss chemical properties of metals and non-metals. Electronic configuration plays a major role in the classification of elements into metals and non-metals. Electronic configuration means how electrons are distributed in various shells, and this electronic configuration is going to decide whether the element is metal or non-metal. Electronic configuration is the basis of chemical behavior of elements. Majority of metals have up to 3 electrons in their outermost shell. Sodium has atomic number 11. Electronic configuration of sodium is 2 electrons are there in K shell, 8 electrons are present in L shell, and last valence shell is M and it contains a single electron. So electronic configuration of sodium is 2, 8, 1. Magnesium has atomic number 12 and its electronic configuration is 2, 8, 2. Aluminium has atomic number 13 and the electrons are distributed like this. K shell has 2 electrons, L shell has 8 electrons and M shell has 3 electrons. So in mostly metals they have 3 electrons at the maximum as the maximum number. This is the diagram of sodium, magnesium and aluminium atoms in which electronic configuration is shown. Sodium has electronic configuration 281, 2, 8, 1. So you can clearly see here 2 electrons are present in K shell, 8 electrons are there in L shell and M shell contains only 1 electron. Magnesium has 2, 8, 2 as electronic configuration. Last shell contains 2 electrons and that are shown by 2 red dots. Circles are made so as to show valence electrons. Aluminium has electronic configuration 283. So 3 valence electrons are there in M shell. This table shows electronic configuration sodium, magnesium and aluminium. The red box shows that 2, 8 is common in all these 3 atoms of metals of sodium, magnesium and aluminium respectively. And in sodium 1 valence electron is there. Magnesium contains 2 valence electrons and aluminium has 3 valence electrons. So metals they have tendency to lose their valence electrons so as to form positively charged ions. Sodium loses its outermost valence electron to form sodium positively charged sodium ion and that is called as cation. Positively charged ions are called cations. So here sodium atom loses one electron and sodium cation is formed by the loss of one electron. Magnesium loses two electrons and two positive charges are developed on magnesium ion. Aluminium loses 3 valence electrons and 3 positive charges are developed on aluminium ion. sodium sodium ion with one positive charge, magnesium ion with two positive charges, and aluminum ion with three positive charges are formed. And positively charged ions are called as cations. So metals have tendency to lose their valence electrons to form positively charged ions, and that is called cations. Sodium loses its one valence electron, and sodium cation is formed in the formation of sodium chloride. And chlorine, here sodium is a metal and chlorine is a non-metal. Chlorine accepts electron and it forms anion, and sodium loses one electron and it forms cation. So metals, they have tendency to lose electrons and they form positively charged ion called cation, and non-metals, they have tendency to accept the electrons and they acquire negative charge, and negatively charged ions are called as anions. Is it clear to you? So in formation of sodium chloride, NaCl, Na plus is positively charged cation and Cl minus is a negatively charged anion. So sodium plus combines with Cl minus chloride ion and NaCl neutral compound is formed. And NaCl is an ionic compound because it forms from the combination of two oppositely charged ions. This slide shows how cations are formed when metal loses outermost valence electron. Sodium ion, magnesium ion and aluminum ion, they are formed by loss of 1, 2 and 3 electrons respectively. And in this slide you can see non-metals, they accept electrons and anion, negatively charged ions are formed. Chlorine accepts one electron, oxygen accepts two electrons and nitrogen accepts three electrons, and anions are formed. So metals, they have tendency to form cations and non-metals, they have tendency to form anions. Is it clear to you all? Reaction with oxygen. Metals combine with oxygen to form their oxides. Metal plus oxygen, metal oxide is formed. The metal oxides are basic in nature. Metal oxides react with an acid to form salt and water. Metal oxide plus acid gives you salt and water. Magnesium ribbon, if it is burnt in air, oxygen from air reacts with magnesium and magnesium oxide is formed. Magnesium oxide react with acid to form salt and water. Magnesium chloride and water will be formed when magnesium oxide MgO will react with hydrochloric acid HCl. So metals, they react with oxygen to form metal oxides, and metal oxides are always basic in nature. Most of the metals react with dilute acids to form metal salts while hydrogen gas is released. So metal reacts with acid, salt is formed and hydrogen gas is liberated. Watch the video which will help you to understand the reaction of metal with dilute acid. Children, I am going to show you reaction of acid with metal. For that, I have taken zinc granules in a test tube. These are the zinc granules. They are taken in a test tube. This is acid, hydrochloric acid. I am adding hydrochloric acid to test tube containing zinc granules. react with acid to form zinc chloride and hydrogen gas will be liberated. Hydrogen gas is highly inflammable gas. It will burn with pop sound. Let us see what will happen when I pour acid into test tube containing zinc granule. Reaction takes place, hydrogen gas is liberated. If I put near a burning matchstick, hydrogen gas will burn with a pop sound. Heat is released. Bubbles which are coming out here, they are of hydrogen gas. Zinc displaces hydrogen from acid and zinc chloride is formed and hydrogen gas is liberated. These are the bubbles of hydrogen gas. Thank you. Reaction with water. Most metals do not show any observable and fast reaction with cold water, but some metals like sodium and potassium react with cold water to produce their hydroxide and hydrogen gas. Magnesium metal requires steam to give similar reaction. So no observable and fast reaction takes place with cold water and metal. But sodium and potassium, they will react with cold water and their hydroxides are formed and hydrogen gas is released. Magnesium requires steam to form similar reaction. So children, we have studied chemical properties of metals, and in next video we will study chemical properties of non-metals.